Welcome to Portnox Cloud University. In this video, we're going to walk through the entire Portnox admin portal, including network access control, zero trust network access, and TACACS Plus. This is not a configuration or deployment video. The goal here is orientation. By the end of this walkthrough, what each page is for, where to find things, and how the platform is organized. In follow-up videos, we'll go deep into individual features and workflows. For now, think of this as building your mental map of the platform. We'll start on the dashboard. The dashboard is your high-level snapshot of what's happening across the environment. It's designed for visibility, not configuration. Here, you'll typically see authentication activity, device and user trends, and high-level indicators of policy outcomes. You can add new widgets to your dashboard, or you can even move widgets around on the dashboard so that you can see the things that are most pertinent to you. As a new administrator, this page becomes more useful once your environment is active. Over time, it becomes a quick answer to the question, is everything working the way I expect? Let's drop an average risk score here on this part. Again, this is not a how-to video, just showing some of the things that can be done on the dashboard itself. So we're going to resize some of these widgets so that the page shifts around and becomes meaningful at a quick glance. Once we have everything the way that we want it and save the changes. With our changes saved, our page is now ready for us, and we can scroll to get to different parts as we need. Next, we move to alerts and events. This is where Portnox records what is happening in real time. Every authentication attempt, policy decision, and access outcome. We can sort by different events, whether it's a wireless connection type or anything else, in order to filter down to what we need to see. We can expand on additional information so that we get the full context of what's happening. Alerts typically represent something that may need attention, while events provide the full activity history. If a user reports an access issue, this page is often your first stop for troubleshooting. While we aren't going to go into a deep dive on what everything means on this page, you can see that it's fairly easy to navigate around and filter. In addition to filtering by any of these categories on the left, we can type into the filter field and sort immediately by a user or device name or any other metadata that we may be collecting. This is especially helpful when you are responding to a user who is reporting an issue in gaining access to the network. We can jump straight to viewing the device. Let's pivot now and take a look at devices. Devices represent anything that connects to the network, be it laptops, phones, printers, other IoT. This is more than an inventory list. Each device record brings together identity, authentication history, posture information, and policy outcomes. Let's investigate some of the things that we can see on a device when we look at its details. We can see everything from security products that are being passed through, patches, certificates, attached peripheral devices, really anything that we are able to gather through the integrations or the agent that we have installed. All of these can be used to inform the device posture and used later on in our policies to alert or exclude devices that don't have what are needed or are missing things that we require on their system. We can browse through devices individually, or using the filter bar, we can filter by name. The iconography in the devices dashboard tells us a little bit about the device, whether it's a Mac OS, iOS, a Windows device, or even just a networking device. We can also see where it's located, if that information is passed along, the risk score. We can deactivate or delete a device, all of that from within this tab easily and quickly. As mentioned, we can sort. We can sort, in this case, Aaron, and it will bring up account names, device names that all have this, making filtering very easy when we need to help people out. We can take a look at the device history here, see if there are any events, and you can see that there are events where something was at risk or access when the device accessed a network, and we can see that over time. Within the devices area, we've also got the network, where we can configure things like sites. It's important to remember that a site in Portnox is a logical container for network infrastructure, all things that share the same authentication and policy setup. This would often be switches. It could be something as simple as a physical site, or it could also be a logical, if we will, site, such as prod, dev, QA, things like that. Here you can see that we've got a few sites, and if we want to add or manage these sites, it's very easy to do from within this area. Maybe the best way to think about it is like this. Portnox is your decision engine. A device is an enforcement point, and a site is a policy boundary. When configuring your sites also, you should give them a name that's very understandable and meaningful within your organization. This will be very important down the road when defining policies. Accounts represent the identities accessing your environment and can be configured from within the devices area. In most deployments, these are synchronized from an identity provider like Microsoft Entra ID, Okta, or Google Workspace, but can be manually configured, for example, contractor accounts or Mac-based authentication, MAB, so that IoT devices can be fingerprinted and added. Here we're assigning the group to which these accounts, when a device joins later, will be associated. We'll see in a little bit the power that groups have in simplifying the management within Portnox. Device accounts are one of the most important and often misunderstood parts of the Portnox cloud. A device account represents any device that we want to join without needing a user account. We can automatically allow devices by type, so vendor, model, OS name. We can make sure that they're a laptop or some other device, and we can even set Boolean like contains or not equals, so forth, so that devices, when they try to access the network, are automatically joined. Once joined, we can again associate them with a group so that the assignments that we make within the groups are automatically applied. A Mac-based account is a network access identity that authenticates a device using its MAC address instead of a username, password, or certificate. Typically, these are used with MAC authentication bypass and often for IoT devices. We can easily add things in based on the MAC. Best practices for MAC accounts are to use only for devices that cannot do 802.1x. Then put those devices in restricted VLANs separate from the corporate network and limit the access to only what is necessary for those. Think of this as a whitelist that grants entry for devices based on their address. A common concern with MAC accounts is that the MAC address could be spoofed. We can either send a warning or block a device from accessing the network if spoofing is suspected. Let's pivot to the Zero Trust Network Access, or ZTNA portion of the platform. Instead of placing users on a network, ZTNA provides access directly to applications and resources. For example, console-based access, or single sign-on SaaS application access, or even application access to applications that are hosted on-prem. Administrators define which applications are available, who can access them, and under what conditions. End users then access these resources through a secure portal without a traditional VPN. This greatly simplifies granting access to important resources that we want to secure without granting access to the entire network, as might often be done in a VPN. So users only have access to the resource and not to the entire environment. Think of this as identity-driven application-level access rather than network-level access. Access is granted to the user via a gateway, which is a container running nearby that provides a secure path between the user and the protected resource. Many think of this as a reverse proxy. You typically deploy these once and monitor them over time. If you were a new user to Portnox, the settings area was probably already set up. If you're new to Portnox, this is where we would come in and configure many of the basic functions of Portnox. Items such as cloud radius or setting up a local radius server. We would define here trusted root certificates. Although Portnox can serve as your CA, you can provide your own. Portnox provides cloud-hosted radius services with optional local proxies for specific use cases. Most environments configure this early and revisit it only when the network changes. If you are a new user, and this is already being configured, this is where you would find the cloud radius information, whether it's for the United States and North America, which is hosted on Azure East, or Europe and Asia, which is hosted out of Amsterdam. As mentioned, local radius services are available and are provided for free via a VMware image, a Hyper-V image, or as a Docker image for those that are running a Docker environment. The TACACS Plus section is used for administrative access to network infrastructure, such as switches, firewalls, and routers. This allows you to centralize administrator authentication and authorization using the same identity sources as the rest of the platform. TACACS Plus policies define what commands or roles an administrator is allowed to use after logging in. Integrations connect Portnox to the rest of your ecosystem: identity providers, mobile device management platforms, in-port security tools, and logging systems. Most environments only use a subset of these, but this page shows how extensible the platform is. Much as Portnox integrates with management tools, such as MDM platforms, it also integrates with authentication repositories, the most common of which are Google Workspace, Entra ID, and Okta. Additionally, Portnox integrates with local domains, such as Microsoft Active Directory. Groups are one of the most important concepts in Portnox. Groups determine how users and devices are categorized based on identity, ownership, posture, and context. Devices and users don't authenticate to a group. Instead, Portnox evaluates them into groups based on certain conditions. Groups are the foundation that policies are built on. We'll dedicate an entire video to group design because this is where most environments succeed or struggle. You can have as many groups as you want it's important to understand that Portnox evaluates to the first matching group for a user and then stops evaluating from there. Policies define what Portnox does once it understands who the user is and what the device looks like. In the NAC portion of the platform, you'll typically see network access policies, risk assessment policies, and authorization logic. If groups define who and what, policies define what happens next. In other words, allow, deny, assign a VLAN, or restrict access. We're intentionally not configuring policies here. This section is about knowing where policy logic lives. We'll cover policy design in a future video. Here you can see what we do when there's successful authentication, when there's an authentication violation, or when there's a risk policy violation. Blocked by admin is a manual process to come in and restrict a device. We can set these up for wireless, wired, or even VPN networks. We can also configure policies for zero trust resources. When defining policies, we define what action Portnox will take, whether it be a device or user authenticates successfully and where they will be allocated, maybe a VLAN. What happens when they authenticate unsuccessfully? Do we deny access or do we put to a restricted VLAN? These are all things that we define within the policy section. A risk assessment policy is a set of rules Portnox uses to decide how safe a device or connection is and what to do about it. Think of it as a scoring or an evaluation system. It looks at signals like user identity, device type, authentication method, site, or connection type even, and it combines these into a risk posture level. It evaluates these things based on definable parameters, such as the presence or absence of administrator privileges, could be running applications or applications not running, whether a device or user belongs to a certain domain, whether there's drive encryption, whether they're a member of an Entra organization. It can use different inputs such as agent P for Portnox-based agent usage, or it can use other integrations in order to define the risk of a particular system. For devices that fail a risk assessment, whose risk posture level is put into a red area, for example, remediation policies can be further defined assuming the agent P is used, such as restarting a service if a service is found to be shut down for whatever reason. This makes Portnox tremendously powerful in automating and configuring your environment. The guest section is a system for giving temporary, controlled network access to non-employees, people like visitors, contractors, or sometimes BYOD devices for employees. Guests are typically not in your directory, and they are only given temporary or restricted access, usually via a captive portal or employee sponsorship. At this point, you should have a clear understanding of how the Portnox platform is structured. In the next videos, we'll go deeper into each area, starting with group and policy design.